That is the number of young developers that this tutor wants to teach how to code.
I can't call him a client because I don't think he's paying us, but our youngest customer, Tanmay, he's somewhere in the audience. I think he's 13.
Please join me in welcoming to the stage, Tanmay Bakshi.
So, hello there. My name is Tanmay Bakshi.
I originally started coding when I was around 5.
Age 9, you created your own app?
Yes, my first iOS app, T-Tables, which helps you learn your multiplication tables, was accepted into the iOS App Store. In fact, on Valentine's Day of 2013.
I am a keynote speaker, an author, an algorithmist, and a YouTuber at Tanmay Teaches. I know that sounds like a lot, but to sum it all up, I love to share my knowledge.
Because I realized that there's this lack of resources for people to learn about technologies like AI.
I'm really passionate about machine learning technology and all the different fields that this technology impacts. There is one field that I'm most passionate about, and that is the field of healthcare. I'm also working towards an app that enables me to provide artificial communication to those who cannot communicate naturally by understanding their electroencephalogram brainwaves through custom deep learning algorithms that I develop.
Madam Speaker, I ask my colleagues to join in a warm Manitoba welcome to 13-year-old Tanmay Bakshi.
Ladies and gentlemen, my joy, my friend, please welcome to the stage, Tanmay Bakshi.
That was just an intro. Tanmay Bakshi, coding since the age of 5, is a Canadian author, an artificial intelligence expert, TED and keynote speaker, and a media personality who has appeared in CNBC, Forbes, Bloomberg, Business Week, New York Times, and the Wall Street Journal, just to name a few. He's addressed over 200,000 executives, leaders, and intellectuals at international conferences and universities and multinationals worldwide. His passion to develop algorithms and to work with machine learning led him to apply this expertise mainly in the fields of education and healthcare. His goal is to help at least 100,000 aspiring coders in learning how to code and innovate. And he does this through his books, workshops, and seminars. Tammy's YouTube channel, called Tanmay Teaches, and his consistent work towards his goal for the past 8 years has earned him numerous recognitions, like the Knowledge Ambassador Award, IBM Champion, Google Developer Expert, Twilio Doer Award, and Global Goodwill Ambassador at LinkedIn, just to name a few. And he is just 15 years old. Presenting Tammy with his Life Mentor Award is the Lieutenant Governor, Honorable Lieutenant Governor Janice Filmon. Please ask you to approach the podium. Tammy.
What a treat we all have in meeting you and having a chance to see your introduction. Before we do any more, I have to recognize your parents, because nobody does anything alone. You obviously were in health, you were wanted, you were loved. And all those ingredients go into making the potential for a very healthy child to make a difference in our world. So at 15, you've done more than what most people could dream of. Because back to what you said, Marcus, you have to have a goal, you have to aim. But to think that your parents ultimately chose to homeschool you starting in grade 6. I have great admiration for both of you and your sister for having contributed to you. But as I said to him, he still's a 15-year-old, a piece of skin keeping in an appetite. Right? That is it. But on top of that, obviously, it's firing up all those neurons and those, everything that goes on. I'm going to have to pull on my science background. Rusty, right? All I know is that you're already making a difference. You've got a big goal. Health and education, and couldn't be bigger or better. And we'll help build healthy communities and make our world better.
Thank you very much once again. Sorry, can you hear me? Is my microphone on? No, it doesn't seem to be. Let's see. Let's try that again. Can you hear me now? A little bit more? No? More. Higher? It's not on. Oh, it's not on. That's it. How about now? You can hear me? No? Can I make it a little bit louder, maybe? Let's see. Can you hear me yet? Good, because I can't tell because I'm actually talking. But anyway, so as long as you can hear me in the back, right? Wonderful, thank you very much. So once again, thank you very much, everyone. It's truly an honor to be the recipient of such a prestigious award. I'm humbled by this. Thank you very much. And again, thank you very much once again to her honor, Janice Filmon. This is really an honor to be a part of this wonderful event and to be the recipient of this award. And I don't just want to say thank you. I want to continue from here and share a little bit more about my story and my passion, and really how I got to doing what I'm doing today, and of course what's in store for the future and how I'm going to continue this journey. Now, essentially, I love working with technology. I love working with next generation technology in particular. It's what I love to do, and machine learning is specifically the one technology that I love working with most. Now, machine learning is something that you may know as AI or artificial intelligence. There are lots of different names for it, and we'll get to that in just a second. But first of all, once more, a huge thank you to Her Honor Janice Filmon for supporting the wonderful work of the Creative Foundation. Again, and of course, none of this would have happened without the teams at the Creative Foundation themselves. So a huge thank you to the team at the Creative Foundation. Yes, huge round of applause. Now, specifically, I want to say a huge thank you to Isa Pimbalaji. Someday, I'm not sure where he might come on. Someday to the picture. Yes, there he is. Or, no, where did he go? He was here just a minute ago. Anyway, but also another huge thank you to Gary Green. I mean, they've been putting in hard work for so many years now to make the Creative Foundation what it is today. And really, they've been working towards empowering, not just supporting, empowering the youth here in Manitoba to follow what they're passionate about. So a huge thank you to them. This is really the manifestation of Isa's vision, what he's passionate about, and I'm so glad to be a part of it. Now, I'm especially excited to be here in Winnipeg because I was actually here 3 years ago for a keynote and a workshop at the Education Disrupt Ed event. And while I was here, I also had the honor of meeting His Honor Cliff Collins, which was extremely exciting. Now, while I'm here in Winnipeg this year, not only am I a part of the 20th anniversary celebrations for the Creative Foundation, but over the next 2 days, with the help of the Creative Foundation, of course, I'm going to be holding a series of 5 workshops at the Fort Richmond Collegiate. Yes. Thank you. This is going to be really exciting. Now, these are computer science students that are going to be attending this workshop, and they've worked with code before, they've worked with technology, and essentially what I'm trying to do is I'm trying to introduce them to the world of artificial intelligence and machine learning, and I really cannot wait to see what they can accomplish with this next generation of technology. It's going to be really, really exciting. Now, as I mentioned, I'm really passionate, personally very passionate, about the initiatives that the Creative Foundation has to offer. And if you take a look, it actually all starts with the very root of the Creative Foundation, the name of the Creative Foundation. And let's expand a little bit more on that. How do humans like to define the word creative? Let's think about that. Now, if you were to search up in the English dictionary how we define creative, you can see relating to or involving the imagination or original ideas, especially in the production of an artistic work. Now, I personally feel like that last part of the definition is underestimating human capability a little bit. I mean, when you hear creativity, the first thing your mind would race to would be art. Maybe a painter, maybe a musician. But that's not the limit of human creativity. Creativity is an innately human skill, and we're all born with it. And actually, a good way to think about it is to ask, well, why are we alive today? Why are we prospering today? Why are we thriving? Specifically, why modern humans? Why not archaic humans like Neanderthals? And if you take a look at the research, there are lots of conflicting opinions. But one of the leading theories is that while Neanderthals were much stronger than us, while they had physically stronger bodies, while they had larger brains, there's one part of their brain that was a lot smaller, the frontal lobe. And the frontal lobe is what deals with creativity, with problem solving, with social interaction. And because of that extra creativity that was lent to us as humans, we were able to come up with ideas, with technologies that no other animal, no other human had ever been able to come up with before. Think agriculture. We were able to invent this new technology of agriculture. And we've also completely shifted the way we evolved to live for millions of years to the new paradigm of living in large towns and cities. Now, this is all thanks to our unique imaginative ability. Without this imagination that we have, this would have all been impossible. And this imagination enables us to unlock one more thing, and that is exponential innovation. Now, when I talk about exponential innovation, there's one way that I like to visualize it best, and that's through the help of a graph. Now, if you were to plot out the gross world product, so the total economic output of the whole world, from 1 AD to 2015, you notice something pretty interesting. For the first 1900-ish years, this graph is basically flat. And then around 1912, there's a little bit of a spike, and then there is exponential growth. Now, why is that? Think about it. Really, it's because with every single innovation, with every discovery we make, that enables us, that empowers us really, to make an even bigger discovery the next time. That's what's so unique about the way that we innovate as humans. And it's not just our imagination and creativity that enables that, it's also our amazing curiosity. I mean, think about it. 5,400 years ago, we as humans invented written language. And when we did, it was a brand new innovation. This was unheard of. We invented this new concept of written language. Now, when we did, people were afraid of this innovation. For example, Socrates, an ancient Greek philosopher, said that writing will create forgetfulness in the learner's souls because they will not use their memories. They'll trust the external written characters and not remember themselves. What he's saying is that writing will make us less intelligent because we're going to write things down and forget them right after. We're never going to remember things anymore. But of course, that didn't happen. Without written language, we wouldn't have anywhere near modern society. But it does go to show one thing, and it's that we as humans instinctively fear change, just like every other living thing, just like every other animal, we fear change. But then again, in psychological terms, we're also the only animal that we know of to have a system too. We can say, you know what, we're curious enough, so we're gonna do it anyway. Even if it could harm us, we think, you know what, there's enough of a pro versus a con, so we're going to do it anyway because we're curious. As a matter of fact, it's this curiosity that got me into the world of technology around 11 years ago as a curious 5-year-old. So let's travel back in time by around 11 years to when I was 5. Now, even though I wasn't generating episodic memories yet, I can tell you one thing for sure. And it's that computers would fascinate me way more than basically anything else. And the reason was simple. It's because they were immersive. Computers are interactive. And I wanted to find out how they work. And because my dad worked as a computer programmer, he saw that curiosity that I had and introduced me to the world of programming and technology back when I was 5. But my curiosity, of course, only grew from there. So I started to use the internet and different books as learning resources. And when I was 9, I had my very first iOS application called T-Tables accepted into the Apple App Store. Now from there, I thought, why not also create content to help people create their own applications? And so that's exactly what I did. I started to create YouTube tutorials on my channel called Tanmay Teaches, ranging in topic all the way from iOS app development and programming to math and science. And this YouTube channel made me realize something. It made me realize that there is a lack of resources for the people that want to get into tech, the people that want to learn how to code. And I know this because every single time I upload a YouTube video, there would instantly be tens of people reaching out to me via email, via YouTube comment, via Twitter, asking questions like, how can I start coding? Or how can I fix this error in my code? Or how can I implement a certain algorithm in my applications? And so I saw that there was a lack of resources, which is why I initiated my goal to reach out to and help at least 100,000 aspiring coders to help them innovate along their journey of learning to code. As a matter of fact, I'm very glad to say that so far, I'm around 13,000 people there, and I'm really always working towards this goal through numerous different media. Of course, there's my YouTube channel, there's the talks, workshops, keynotes that I conduct at schools, universities, and conferences across the globe. Basically, making it so that if I learn something about the world of technology, I'm able to make that simple for others to learn about as well, so they can leverage it, they can apply it where they believe it can make an impact. And really the reason I'm working towards this goal is because we can all agree that technology is important today. But its importance is going to grow exponentially in the future. As a matter of fact, Mark Anderson, who you may know as the co-author of the world's first major web browser, says that in the future there will only be two types of jobs. Those in which humans tell computers what to do, and those in which computers tell humans what to do. So, if you want to be on the other end of that spectrum telling computers what to do, you've got to be able to communicate with them in the first place. And so that's really why I'm working towards this goal. And so to scale up the number of people I could reach out to, I decided to start writing my very first book called Hello Swift, iOS App Programming for Kids and Other Beginners. As a matter of fact, I'm very glad to say that just around 4 months ago, my very first book, Hello Swift, and my second book, Cognitive Computing with IBM Watson, have both been published. And I'm also very glad to announce that I've partnered with McGraw-Hill Education on a brand new series of books called Tanmay Teaches. And the very first book in the series, called Tanmay Teaches Julia, is coming out this November. Now, Tanmay Teaches Julia, of course, on the Julia programming language, a language purpose-built for the future of computing. And this book in particular is the perfect springboard for beginners of all ages to get into the world of machine learning and all sorts of next-generation technology. In fact, speaking of next-generation technology, back when I was 10, I was working with technology. I had this goal of reaching out to 100,000, I was creating YouTube tutorials, I was working towards writing my first book, but I still kind of felt like something was missing. There wasn't that next challenge to work towards, and I wanted that challenge. I wanted something challenging to work towards. And I was lucky because one day, I stumbled upon something that completely redefined for me what it means to compute. And that was the day I stumbled upon a documentary on IBM Watson, and how it not only played, but also won the Jeopardy game show against the two best human competitors on the game show, Ken Jennings and Brad Rutter. Now, when I stumbled upon this, I was immediately fascinated. I mean, think about it. 9 years ago, with the computing power and the algorithms available back then, Watson was able to not only understand and comprehend, but also correlate Jeopardy clues with 4 terabytes of unstructured natural language information on its drives. And Jeopardy clues are incredibly complex. They're not easy. Even humans have a difficult time parsing them, forget actually correlating them with past experience. And so I was absolutely hooked. I mean, nowadays we kind of take this for granted. You can talk to Siri, there are chatbots everywhere, but even today, this technology is incredibly complex. And back then, this was unheard of. And so I wanted to find out how I can use this technology in the applications that I've developed. And really, ever since then, I've been hooked to integrating all sorts of machine learning and artificial intelligence techniques in practically all of the different applications that I've developed. But even though this technology is so powerful, I believe it's still the most commonly misunderstood technology in the world by far. There's no one clear definition of what machine learning or what AI is. But really, from a technical perspective, if you were to take a look at machine learning and you boil away all the excess, and you just take a look at the very core of machine learning and what it aims to do, it's actually really simple. It's basically offloading a task from a human to the machine. What task exactly? Well, to talk about that task, take a look at this image. Pretty simple, it's a dog. You know it's a dog. Instantly, as a human, you tell it's a dog. But then take a look at this image. Totally different. It's a cat. Of course you can tell it's a cat as a human instantly. Now, if I were to ask you, any one of you, to write a list of steps, like step-by-step instructions, of how you can take an image and determine if it's a cat or a dog. And I'm not talking about high-level instructions. Like look at the shape of the eyes or the ears or the tail or whatever. I'm talking mathematical instructions, like analyzing pixel values and determining if it's a dog or a cat. That's next to impossible. In fact, no human has ever been able to write those rules because there's simply too many of them. There's nearly an infinite number of combinations of lighting and camera settings and types of dogs and cats. It's impossible to write those rules manually. But with the power of machine learning, what you can do is you can say, all right, I've got these thousands of images of dogs, and thousands of images of cats. And now what I'm going to do is I'm going to feed it into an algorithm that does some fancy math. And what it's going to do is it's going to look at all these images, and it's going to try and find some correlation between the input you provide and the labels you provide, saying, this is a dog, this is a cat, thousands of times. And then what happens is you get a mathematical model, a set of numbers, a set of weights, is what they're called technically. And you can bottle those up and store them. And here's the interesting part. Let's just say in the future, you have a new image and you want to determine if it's of a cat or a dog. You just open up that model, run it through, and it gives you a prediction with a certain amount of confidence as to what that image contains, even if it's never seen that image before. That's what machine learning does. It offloads that algorithm writing task from a human to a machine. Now, this is a very, very oversimplified view of the world of machine learning. There's a lot more intricate stuff that goes on in the back end. However, just know that the basis for cat-dog classification leads to a lot more technology that you're using every single day. Like for example, when you open up Google Maps or Apple Maps, you're not just getting the shortest path anymore. They're using machine learning to predict traffic in the future so you can take the quickest path, not just the shortest path. When you eat produce, and produce wasn't created the same way that it's been created for thousands of years now. Now we have smart agriculture. So farmers can use less resources like water, but still get more yield because of the fact that they are using their resources more efficiently in an optimized way. And oncologists aren't just using technology to store their data more efficiently. Oncologists are now using technology to offload a certain amount of the diagnosis work onto the technology, so they can focus on the part of their job that actually requires human creativity. And that's what really matters. And so I've been working towards integrating this technology in a variety of different fields. But of course, the two main fields that I'm most passionate about are the fields of healthcare and education. And so out of the many projects that I'm working on in these two fields, there are two projects in particular that I want to share with all of you. These are two projects that I think you'd be most interested in. And it starts off with a project of mine in mental health. Now, mental health is a notoriously difficult field to work with because of course, restriction of data, and also the fact that data is extremely complex in mental health. But that's not to say that the data isn't there, because this is a very serious problem, and it's already been proven time and time again that the data exists. As a matter of fact, over 80% of all the teens in the US that do commit suicide give off clear warning signs before it happens. But the problem is, humans can't detect those warning signs. You can't track the thousands of data points from millions of individuals instantly with human intelligence. It's impossible. But while computers can look at that data, they can't analyze it. They can't find patterns in it. They can't determine what it means. And so I'm getting the best of both worlds, finding patterns in data at scale with the power of machines. I'm able to implement AI systems that can actually analyze the passive data that you're generating every single day without even realizing it in order to create an early warning system for depression. And so that's what I'm working on in terms of custom machine learning algorithms and AI systems in the field of mental health. And now, in the combined field of both healthcare and education, there is one more project that I want to share. And instead of me just introducing it to you, I want to ask you all a question first. Now, think about this in your head. 3 people on screen right now. Richard Branson, Walt Disney, and Tom Cruise. Now, what's the common thread among all 3 of them? You might think about it, you might say they're rich, they're successful businessmen, they're intelligent, and you'd be right with all of these. And I'm sure you could keep going on and on. But there's one thing that you may not know off the top of your head, and that is that all 3 of them suffered from dyslexia. As a matter of fact, 10% of all Americans suffer from dyslexia. I mean, think about it. If you were born in America, there's a 10% chance that you suffer from dyslexia. That's a huge percentage of the population. But being dyslexic does not mean you're less intelligent than anyone else. As a matter of fact, the vast majority of dyslexic individuals are usually more intelligent than their non-dyslexic counterparts. However, their brain is trying to use the wrong side of their brain to read. That's the issue. Now, with enough practice, their brains can develop neural pathways to force the other side of the brain to read, so they can read fluently and they can comprehend written language. But it's very redundant, it takes a lot of work, it's repetitive, it's boring. And of course, a young dyslexic student probably doesn't want to do all that. And so this is where machine learning comes in. By using machine learning technology and using AI systems that I develop, I can, for the first time, create intuitive experiences when it comes to teaching dyslexic students to read. Modern applications that run on practically any hardware that use machine learning powered interventions to make this experience fun, to make it interactive, to make it intuitive, which is something that we simply could not have done in the past. And so these are just some of the projects that I'm working on in the fields of healthcare, in the fields of education, and more. But I still feel like my talk at the Creative Foundation 20th anniversary celebrations would be incomplete without talking about one more project. And this is a project that uses AI in the field of art, creativity when it comes to art. Now the project's name is called Make Your Own Mozart. And I personally feel like the title is self-explanatory, so instead of me talking about it, I want you to listen to it instead. And we're going to have audio from my computer this time. Was a music clip that I created. But I'm not a musician, so how did I do it? Well, I created a machine learning system, an AI system, to create it for me. And I trained this on piano sonatas from Mozart and Beethoven. Now, I did train it on piano sonatas from Mozart and Beethoven, but then I scaled down that model and retrained it on folk songs to keep it simpler for this demo in particular. Now, I want you to note one thing. I know it sounds like and it feels like this computer system was creative, but the point of the system is not to replace great artists like Mozart and Beethoven. That's not the point at all. What I'm trying to prove here is that using a mathematical model, using fancy math, you can find patterns in human-generated data, even music, and you can restructure those patterns in ways that seem novel, but actually are not. Now, there's a finite number of things that this model can do. It will run out of options of ideas eventually. This will keep on restructuring the same old pattern. So it's not human creativity. Human creativity is truly irreplaceable because of the practically infinite things that we can do with it. And so this is just one of the many reasons I personally believe we shouldn't be afraid of artificial intelligence technology. In fact, I don't even like to call AI artificial intelligence. I like to call AI augmented intelligence. Because if you think about it, that's what it is. It's about augmenting human capabilities so we can do more with the power of the technology that we already have in our everyday lives. And I really cannot wait to see how we can use and we can take the help of initiatives like the Creative Foundation to really bring this technology to the hands of more and more people across the world. So we can make really not just Canada, but truly the whole world a more creative, a more connected, and of course, an overall better place. Thank you very much, everyone.